Hi everyone, welcome back. In this video, we'll see preemptive priority scheduling algorithm. Guys, in general, priority scheduling algorithm is going to work on the factor of priority. Means, if the process having the highest priority, then it will be allocated first CPU. Later, it will give chance to the next highest priority process. Here, the mode will be preemptive mode, they have given clearly, and the criteria will be priority, which you know it already, right? If you have any doubts regarding this algorithm, just go with the earlier videos so that you can get the clear idea, right? Guys, this example is somewhat different from the earlier examples. This example contains burst time at the first, then IO time, then again they have given with the burst time, which means when a process is in ready state, it will convert it to running state after certain kind of time based on the scheduling algorithm. When it is in running time, it will be called as burst time. After certain time, which is executing the CPU, it will go for IO operation. IO operation, we can call it as wait state or block state. That is what they have given. How much time they are going to be in the IO process, that will be defined by here. Fine. Then it will enter into the ready state after completion. Means after IO completion, it will come to the ready state. Then after getting into the running state, how much time it is going to be in the running? That is what they have given here. So and arrival time, priority they have given. So without wasting any delay, let's try to draw Gantt chart in order to define how these processes are executing. Right? You know, this is a CPU with 0 units of time. At 0 units of time, what is the process available for us? P1. You have to make sure that, guys, it's a preemptive algorithm. Means at any point of time it can come out based on the higher precedence process. And how are we going to define the higher priority? The lower number having higher priority number having the lower priority. Hope you understood, right? As we are having only one process at 0 units of time, I can give chance to CPU. Use the CPU, right? So P1 execute for 1 unit of time. As it executes 1 unit of time, it is left with 0. Means it has done 1. Right? As it done 1 unit of time, it will immediately move to IO. Means IO operation it will wait for how much time? 5 units of IO operation. Means when it will come back again after 6 units. After 6 units, it will come back. Up to that time, you should not disturb the P1 process. Means this will be done. Now, is there any process available for us right now? No. Means at 1 unit of time, there are no process available. So, it will wait for 1 unit of time. By the completion of 1 unit of time, means 2 units, P2 is arrived. As only P2 process is available, because P1 is already went for IO operation, it will give chance for 1 unit of time. As I am giving 1 unit of time, it will done by 3 units. As it completes 1 unit of time, it is left with 2 units. 2 units, right? Now observe, by the completion of 3 units, there will be another process which is added to the ready queue. Means now P2 and P3 both are available for us. P2 and P3 both are available. As P2 and P3 both are available, now it has to schedule which process? That depends on priorities. So we are having 3 and 1 as priority. The lower number having higher priority, which means P3 will be allocated. P3 will be allocated for 1 unit of time, completed by 4. By the completion of 4 units, what are the process available? Again P2, P3 only. Which is having the highest priority? So it is done with 1 unit. 1 unit. So which is having the highest priority? Again P3 only. P3, 1 unit done by 5, which means now it is left with 0. Left with 0. By the completion of 5 units, what are the process available? And this process is went for 3 units of IO operation. And it will complete it by 8. It will come back by 8 units of time. Right? At 5 units of time, what is the process available for us? P2 is available for us. So P2 will give chance for 1 unit and it completes 6 units. It is left with 1 unit, right? By the completion of 6 units, there will be one more process which is readily available for us. That is what? P1. P1 is readily available. Now means P1 is available and P2 also available. Why P3 is not available? Because it will complete by 8 units of time. As P1 and P2 both are available, which one will get the highest precedence? Highest precedence will be given to the lower number. Lower number is what? 2 here. Which means P1 get the chance for 1 unit of time. Means it will be done by 7. So left with 2 units. By the completion of 7 units, what are the process available for us? Again P1 and P2 only. Given chance to P1. So left with 1 unit. That will be done by 8. Guys, this is done. By the completion of 8 units, P3 is readily available for us. Means now what are the process available for us? P1 is available, P2 is available, P3 is available. 3 process are available. Now which one will get the chance? The process which are having the lowest precedence. Lowest number. Lowest number is related to what? 1. Means now P3 will get the chance for 1 unit of time done by 9. Means this is also done. Means this entire thing is done. Now, remaining 2 are there, P1 and P2. Which one will get the chance? Again P1 got the chance. Done by 1 unit of time, done by 10. Now, P1 is also completed. As P1 is completed, P2 was in left, so I can give chance to P2 for 1 unit of time, done by 11. Then it will go for IO operation, which means it will go for 3 units of IO operation. As done by 3 units of IO operation, it will come back by what time? 14. So as they are left with only one operation, it will come back by 14 and it will be done with the 1 unit of IO operation. That means P3, then it will complete by 15. Okay. So this way, your preemptive priority scheduling algorithm work for you if this kind of data set is given for you, right? What is schedule length here? Schedule length will be 15 minus 0, that will be 15. What is the CPU utilization? CPU utilization will be out of 15 units, how many units are efficiently used? So this will be 1 unit, this will be 3, total 4 units. So 11 units are efficiently used. 11 by 15. So 11 by 15 means I can say 73.33% is the effective utilization of CPU. Right? Hope you understood this video clearly.